Welcome to the Introduction to Lua Programming class. The goal of this class is to go over the basics of programming, as well as the fundamentals of using Lua. If you've never programmed before, this class will be perfect for you to get your first taste of what coding is like, and learn all of the concepts that are used throughout all programming languages. If you already have some coding experience, you'll pick up on the basics of Lua very quickly. The videos on tables are a must-watch though. That's what really separates Lua from other languages. At the end of the class, you'll be assigned a project, which will be an excellent opportunity for you to experiment with the language and build something cool. Getting started with Lua is very easy. I'll be going through each lesson just in a web browser. If you go to lua.org, you can go to this download link, go over to Live Demo, and there's a few different sites here that you can choose from. Each of these have a small text section over here that allows you to write Lua code, and you can run it directly in the browser. Once you're all set up, go ahead to the next lesson where we'll write our first bit of Lua code. The very first thing that we're going to discuss is variables. A variable is a piece of stored data whose value can be changed. To demonstrate this, let's go ahead and put one into our code. At the top of the file, I'm going to write message equals, and then in quotation marks, Lua is awesome. In this line, we just created a variable. The variable's name is message, and the value that this variable contains is the text Lua is awesome. Now, to make sure that we did this correctly, let's print the value of this variable. So in print, instead of hello world, let's go ahead and pass in message. So that when we run, we'll see the text Lua is awesome. It's just going to grab whatever value this variable contains. And all kinds of data can be stored. In this case, it's storing text. And in programming, text like this is called a string. A string is just some words or letters surrounded by quotation marks like this. A variable could also store numbers. For example, we could set this message variable to 5, just the number 5. And keep in mind that we do not want quotation marks around 5 because we want it to be treated as a number, not a string. And same deal as before, if we're printing out the value of message, we should see 5 over here in the output. We can have pretty much as many variables as we want. For example, let's put in another variable, and I'll call it chicken. And let's set it equal to 10. So now we have a message variable, and we have a chicken variable. But even when we run, it's still going to say 5 over here because we're printing message specifically. Let's make a third variable, and we'll call this one result. But this time, let's do something a bit different. Instead of setting it equal to a new value, let's set it equal to chicken. So now, the variable result now contains whatever value chicken has. So since chicken has 10, and let's try print result this time, we should see 10 in the output because result contains whatever value chicken has, and we're printing result. When programming, the value stored in a variable could change later on in the program. So even though, for example, chicken starts off at 10, I could later on change it to chicken equals 25, for example. And when we print chicken, we should see 25 because even though it starts off being 10, this line changes it to 25 and we print it out at that point. But this result variable is set to chicken here on line 3. And at this point, since the program runs from top to bottom, chicken is set to 10, result is set to chicken, meaning that result actually contains 10. And we can see that if we print result and run, it is 10. Another way that variables can change in your program is by performing basic arithmetic on them. What this means is that we can do addition, subtraction, multiplication, or division with these variables. So let's try that out with result. Instead of setting result just equal to chicken, let's set it equal to chicken plus 1. So what this does is since chicken equals 10, we'll see 10 plus 1, and when we print result, we will see 11. It performed this arithmetic right here. And you can perform any kind. Like I said, you can do -1 or times, say times 20. We'll see that says 200, or you can do division. And similarly, we'll get the decimal value. Keep in mind that this math only works when we're working with numbers. If, say, chicken was a string, like hello, Well, this suddenly becomes strange because we're trying to take the string hello and divide it by 20, and that doesn't really make sense. In fact, when you try to run, we'll see an error. And when you're programming, it's very common to run into errors. It's just a natural part of learning and just a natural part of programming. Even experts run into errors. And here we can see that it is attempting to perform arithmetic on a string value, global chicken. So you can't perform arithmetic on strings, and that's why we would need to change this back to a number in order for this to run properly. And even after a variable is already initialized, we can still change its value later on with arithmetic. So with chicken, for example, I could say chicken equals chicken plus 10. So here we have chicken starts off at 1, and then this line is going to set chicken equal to the current value of chicken, which is 1, plus 10. So that should give us 11, and if we print that out, we will see 11. That about covers the basics of using variables. These are the foundation of any program, and having a good idea of how they work will make you a very capable developer. Next up, we're going to cover if, else-if, and else statements. These types of statements may be known as conditional statements because they determine whether or not a section of our code will run at a given time based on a condition. We're going to start off with our code looking like this, where we have a message variable and we're printing it out, and when we run, we just see 0 over here. But also, let's add another variable to the program, and I'm just going to call it condition. You can call it whatever you want, and you can also set it to whatever you want. I'll set it equal to 25. We're going to use this variable as part of a conditional statement that's going to change the value of message. We're going to start with an if statement, and that starts with if condition is greater than 0, then, and then end. Now between this then and this end, we're going to put what actually happens when the condition is true. So I'm going to set message equal to 1. So this line reads as, if the value of condition is greater than 0, then, and only when that condition is true, it's going to perform what's in here. It's going to say message equals 1. And we can test that. Message starts off at 0, but if we run, we can see that it goes to 1. And alternatively, let's change condition to negative 25. So now, this if statement won't be true anymore because negative 25 is not greater than 0. So since this condition isn't true, that means this line here won't run. And again, when we run, we see message remains to be 0. This line never happens. We're going to add another conditional statement to our code, and it's going to be a really similar idea to before, but this time it will check to see if condition is less than or equal to 0, then. And in here, we'll set message equal to negative 1. So same idea as before, it's going to see is condition less than or equal to 0. And only if that's the case will message be set to negative 1. And we will see that that happens. This line is reached because its condition is true. But again, all of our programs happen from top to bottom. So first this line happens, then this line, and then it's going to check this condition. And in our case, this condition is not true. So this line does not happen. Then it moves on to this condition. And since this one is true, this line does happen. Now, writing our code this way with two separate if statements, one right after the other, is acceptable, but there is a much easier and more efficient way of writing this exact same thing. So I'm actually going to remove this second condition, or the second if statement, and instead we're going to add to this first one. I can put in else and say message equals negative 1. So this is a new type of condition where it just says else. So the way this reads is it's first going to check this condition. If condition is greater than 0, then this line happens. But if this condition is not true, or if condition is less than 0 instead of greater than, then it's going to say else. And once this else is reached, then whatever is between else and the end is what gets run. So in this case, message equals negative 1. So this is the exact same functionality as before, but it's more compact with just one single set of if and then else. And we can test this. If we run, we still get our negative 1 in output. So far we've used if statements, we've used else statements, and finally we're going to move on to the last conditional that is sort of a combination between these two, and it's called the else if. Let's go ahead and put one into here, and I'm actually going to remove our else for now just to clean it up a bit. But in its place I'm going to add the else if. So you say else if, one word like that, and we'll add a condition to this. Condition is less than -10. Then, and in this case, we'll say message equals -1. So this is different than before because with our else statement, there was no condition attached to it. So what's going to happen is this condition is going to check first, and if it's true, we're going to do this. But if this condition is not true, it's going to move on to here, else if, and it's going to check this condition. And if this one is true, then this line here is going to run. But if neither of these conditions are true, then neither of these lines are going to run at all. So testing this out, since condition is -25 right now, we still get our -1. But if we change this to, say, -5 instead, so with that, -5 is not greater than 0, so it moves on to the else if, and -5 is not less than -10 either, so neither of these conditions were met, and that means that message remains at 0, what it starts at. Now to tie everything together is that you can put an else in addition to everything else. So I'll put message equals, and let's set it to a string, no conditions met. So with this -5 example, this is not true, this is not true, so the else is going to be hit, and this line is going to happen. So we can see if we run, no conditions met. Now with blocks of code like this, you can have one if, you can have one else, but between the else and the if, you can have as many of these else if portions as you want. So I'm going to put in another one actually. I'll say else if condition, and we'll say is equal to -5. Then, and in this case, I'll say message equals hello. Now keep in mind that I'm using the double equal sign here. When you're using double equal sign, that's how you're testing to see, is this equal to this? But when you're using one equal sign, that's called an assignment, meaning that this value is being directly assigned to this variable. So we're not setting condition to -5, we are testing to see, is condition equal to -5? And if it is, then this line will happen. And we can test it out. If we run, we will see hello. One final comment on this topic is that in these intersections, you can have as many lines in here as you want. So in addition to hello, I could do like an extra print and say hi. So when I click run, we get both the hi and the hello. Both of these lines run because everything between this and this, the entire inner indented section, that's going to be run. The next topic is loops, and there's a reason I'm showing you these right after conditional statements. Loops are sections of code that run more than just once based on certain conditions. To show this off, we'll jump right in with our first type of loop, the while loop. I'm starting with the code looking like this, where we have our message and we're printing it out. And after the message, we're going to write the first loop, and it's a while loop. We'll say while message is less than 10, do. And then in here, let's say message equals message plus 1. Let's go through this section of code line by line to get a better understanding of what it does. We start with while, and then this message is less than 10. So this is really similar to our if statements, where this is a condition, and only if this condition is true do we go on to the intersection. And inside of this while loop, we are saying message is equal to the current value of message, which is 0, plus 1. So after this line runs, that would mean that message would equal 1. But what makes loops interesting is that once it reaches here, the end, it's actually going to jump back and to go while message is less than 10. So it's actually going to check the condition again, right after it checked it the first time. And message is now 1. So it's going to ask, is 1 less than 10? And since it is, that means message is going to increase to 2. And then once again, I'll go back here, is 2 less than 10? And then now it's 3. Is 3 less than 10? And over and over and over, it's going to keep looping, which is where the name loop comes from, until finally message is going to increase to be 10. And it's going to say, is 10 less than 10? And since 10 is not less than 10, that means that the condition is no longer true, and this intersection stops running. It does not run anymore after that. And then it moves on. So after this runs, that means that this intersection ran a total of 10 times, and message ended up being 10. And we can see that. If we print message and run, we see 10. Keep in mind that this whole process that we just talked through happens instantaneously. Since computers are incredibly fast, the program comes across this while loop here and can almost immediately get through all iterations. You could even jump this 10 up to 10,000, and it's still going to run instantaneously. It gets through all 10,000 iterations in no time. Speaking of, this message equals message plus 1 is a very basic example. Between the do and the end, you can have as much code as you want, just like the if statements, and all of it will be executed as long as the condition is true. For example, we could add a second variable. I'll go ahead and just call it test, and I'll set it equal to 0. Then within the loop, let's do something like test equals test minus 5. So I'm also going to drop this back down to 10, so it's a little bit easier to understand. So just like before, this loop is going to run 10 times, which means that this line here is also going to run 10 times, which means that test, if we print out test, will be negative 50, subtracted by 5 10 times. Earlier I mentioned that the loop will run until the condition is no longer true. And as a programmer, it's your responsibility to make sure that whenever you use a while loop, it will eventually end. Otherwise, your loop will keep going on and on forever. And just as a learning experience, we can go ahead and try it out just to see what happens. What causes the loop to end is this line, because message keeps growing until message is no longer less than 10. So if we change this to minus 1, well, now this loop is going to keep going on forever because message will always be less than 10. So if we run, we can see that we kind of get stuck. So if you go, it actually times out. If you do this on your own computer, be careful. You might have to force close the program. But yeah, that's what happens whenever the while loop runs forever. It just never stops and it times out. So before we forget, let's change this back to plus, and we are back to normal. That about covers while loops, so let's move on to the second type of loop, which is called a for loop. This kind of loop is just as useful as the while, but it's useful for different situations. In programming, you'll notice that there's normally many ways to do something, so you'll always have options for how you go about solving problems. Let's start by making a new variable again, and I'm going to just call it pickle. It doesn't really matter what you call it. And I'll set it equal to 0. And this is the value we're going to print out, pickle. And after the while loop, we're going to start the for loop. And this is what it looks like. You say for I equals 1, comma, 3, comma, 1, do. And then inside here, let's do pickle equals pickle plus 10. Now looking at this code, it's a little less self-explanatory compared to the while loop. So let's go through it bit by bit so we can better understand what's going on here. This first line specifies 3 different values. First we have I equals 1. In a for loop, this is going to act as our iterator, which basically means that it's a value that's going to be updated every time this for loop loops. The next number in the sequence, this 3, is the number that our iterator will approach, and once that number is reached, the loop will end. And finally, this last number is the step value for the loop, or in other words, it's the amount that our iterator will increase by every time this loops. So I know that was a lot of information all at once, so let me go through what will happen when this loop runs. The loop will start, I starts off at 1, and again, this is our iterator. So the loop begins, pickle is going to increase from 0 to 10. So 0 plus 10 is 10. So now pickle is 10. Now the loop ends, it goes back to the start, but this time I increases by this value. So I increases from 1 plus 1 is 2. So now I equals 2. And since 2, the current value of I, is less than this value, the 3, that means the loop will continue. So we're going to go into the loop once more. Pickle is going to increase by 10 again, so now pickle is 20. And again, we go back to the start of the loop. I is going to increase from 2 to 3. So now I is equal to 3. Now that I is equal to this middle number, 3 is equal to 3, that means that this is the last iteration of the loop. So pickle is going to increase by 10 one more time, and then the loop is finally done and it moves on. So that means this line in the middle here, or I should say this whole section, ran 3 times total, the 1 to 3. So we can see that pickle, after all of this, should be 30. Now, at face value, this loop might look a little bit more complicated than the while loop we did earlier, since there are a few more numbers for us to keep track of. But once you're used to it, I think it's pretty self-explanatory. The loop will start at this number, increase by this number each time until it reaches this number. So it's an easy way to have a predetermined set of loops. Something interesting and very useful that you can do with for loops is that you can use this iterator value inside of the loop itself. So, for example, I could increase pickle by I. What this means is that I is going to start off at 1, so pickle is going to increase by 1, then it's going to increase by 2, and then it's going to increase by 3. So 1 plus 2 plus 3 is 6. This is a really common way to use for loops because there will be many circumstances where you'll need this iterator value in order to perform certain calculations. In programming, it's important to remember that copying and pasting your code is not very good practice. If you ever find the need to copy a section of your code and paste it to another spot so that there's now 2 copies of the same code, you should instead consider using a function. A function is a section of code that you define, and then you can call that section of code to be ran elsewhere in the program. You'll understand what I mean in just a moment. We're starting off the code with just message equals 0 and then printing message, which outputs 0. But after message, we're going to write our first function. We're going to say the function keyword, and the name of our function will be increase message. And then inside of this function, we'll say message equals message plus 5. So here, function keyword indicates that the next thing is the name of our function. The 2 parentheses is necessary to indicate it's a function. And then everything before end, so whatever's here, this is going to be run whenever the function gets called. Now, by default, just because we define this function, that doesn't necessarily mean that this code is going to be run off the bat. Like if I click run, we'll see that our output is still 0. In order for this code to be executed, we need to call the function, which just means we type the function name, increase message, and then put the 2 parentheses. So this is referred to as calling the function, which just means that when you type this line, it's going to take whatever code is inside the function and run it. So we'll see now that when we run the whole program, our message value is 5. And similarly, to demonstrate this, I could copy this function call and say, call it 2 more times. So we're calling this function 3 times total, which means that this code is going to run 3 times, which in the end means that our message is 15. Now, we're going to make the function a little bit more interesting. When you're writing a function, you have the option of giving it parameters. Parameters are what go in between the parentheses, sort of like what we're doing with this print function down here. We could change it so that this function accepts 1 parameter. We'll say it accepts something called foo, and then we can use this parameter in the function. So we'll say plus foo. So instead of adding 5 each time, it's going to add whatever value we pass in. So when we call increase message, I can put in whatever value here that I want. So I can say 99, for example. And when I run, we got 99. But I can also call it a second time, increase message, but this time I'll pass in 2. And this time it's 101. It called this code twice. The first time foo is equal to 99, and the second time foo is equal to 2. Although in our example we only have 1 parameter in this function, you are able to put as many in there as you want, and you do this by putting commas between each one. So if I wanted another one called val, and another one called me. It doesn't matter. You put them all in an order, and then when you call the function, you would pass in additional values for each one of those parameters. So this is how that would look if you wanted to do it that way. Now, one very important thing to know about functions is that you have the option of returning a value. To explain what this means, let's go ahead and alter our function so that it returns something. I'm going to clean up this code a bit, so we're just back to the one parameter foo. So instead of having message increase by just the value of foo, let's make it so that foo equals foo times 2. So we're going to pass a value in, and then immediately we're going to double that value, and then let's return foo. So now the function's behaving a bit different than it was before. Before, we manually said message is going to increase by foo, but now we're just changing foo and then returning foo. So what happens is, in order to actually apply this function to message, we would say message equals increase message, and then let's pass in 10. So what's going to happen here is this 10 is going to be passed in as foo, then foo is going to double, so that 10 is going to turn into 20, and then it's going to return the new value of foo, which, like I just said, is 20. So when something gets returned in a function, that basically means that the function call is going to replace itself with the result. So since we were returning 20 up here, it's basically the same thing as replacing itself just with the result. So it's basically doing that. But the beauty of it is that you're able to pass in whatever value you want, and it'll take this and apply it. So in this case, I typed in 99. The result is 198. It just doubles this value, and then since we're setting message equal to this returned value, that's what we get in the print. The reason why this is useful is because now if I wanted to apply this function to, say, a new variable like chicken, the way I had it set up before, where I manually said message inside of this function, that would mean that it only applied to this variable and that's it. But now when I'm returning something, I can use it for any variables. So I could say chicken equals increase message 5. And then if I print chicken, we should see 10. A cool thing that you can do with functions is pass other variables as parameters. For example, at the top of the program, let's make a new variable. I'll call it monkey, and let's set it equal to 100. Then what I can do is I can pass this monkey variable, let's say, into here. So I'm going to just say monkey. So what's happening is the value of monkey, which is 100, is going to get passed into increase message and then get applied to chicken, which results in 200. Having functions in our tool belt will be incredibly useful as you move forward with programming. You'll see how often sections of code need to be ran at different points in the program, and it's a lot easier to manage everything when the code is in one place rather than copy and pasted throughout the file. So far, everything that we've written in our Lua file has been Lua code. But with pretty much every programming language, there's an option for programmers to put in little notes that are not treated as code. And these notes are called comments. For example, here in this code from the previous lesson, we have a function that's called increase message. If I was writing a bunch of code and I had a ton of functions written throughout my files, it might be difficult to keep track of what each function does, so it's helpful to write comments into your code to help you remember. In Lua, you write comments by typing dash dash, and then everything after it is considered a comment. So I can write my message doubles a value and returns it. So this message here is ignored by the program, but it helps me, or whoever's reading my code. It just gives you some extra context. It's a little reminder. A cool trick that you can do once in a while is called commenting out some code. Comments are helpful for these little reminders like this, but you can also use it to disable certain sections of code. So for example, if I wanted to see what would happen if I completely removed this line, I could delete it, or maybe I want to just temporarily delete it by doing dash dash. Now this line is considered a comment, and when I run the program, it basically pretends like this line isn't there at all. But at the same time, it's really easy for me to bring it back. There's also the option to treat entire sections of code as comments, and you can do this by typing dash dash square brace, And then when you want to end the section of comments, you do square brace, square brace. So everything between this and this is considered a comment, so neither of these lines here are going to be run. Getting into the habit of commenting your code is really important. It helps for your own note-taking, but if someone else wants to look through your code, comments make a huge difference in understanding what you, as the programmer, were trying to do when you were writing it. Reading other people's code can be difficult at times, but having comments to guide you along the way makes the process a lot easier. In Lua and lots of other programming languages, there are two types of variables, global variables and local variables. So far, we've been working with globals. Global variables are things like message. Once you define it, it can be accessed anywhere throughout the program. And that's what global refers to. We could type message anywhere in the file, and the program would know that we're referring to this variable up here. The alternative to a global variable is a local variable. And all you have to do in order to make a variable local is add this local keyword beforehand. And as the name implies, the local variable can only be accessed within the same section of code that the variable was declared in. So for example, let's update this increase message function to do something different and utilize a local variable. I'm going to make a new local variable in here and call it local var, and I'm going to set it equal to foo. Then on the next line, I'm going to do var equals var divided by 2. And then finally, we're going to return var. So now, rather than doubling the message, we're now cutting it in half because we're setting var equal to the passed-in value, cutting it in half, and then returning var. But it's important to note that the variable var is only going to be used in this section of code inside the function. And since that's the case, using local here makes sense. We wouldn't want var to be utilized anywhere outside of this section of code right here. And that's where local becomes really useful, is when you're managing your project. When there's a large amount of variables throughout your program, it's more likely for a mistake to be made when there's lots of different globals, because if you made a second variable later on, and I called it var, well, it might not be clear which var we're talking about. But if everything is local to its relevant section of code, there would be no mistaking which var this is referring to, just in case you named two variables with the same name. So this is a habit I highly encourage you getting into, especially with writing functions. I would say this is a very common scenario where I use local variables because I don't want these variables to be used outside of the function that I'm declaring them in. Everything that we've covered so far is very common in the programming world. You'll find all of these things in pretty much any language. However, our next topic is tables, and this is a data structure that's pretty unique to Lua. Every language is going to have options that are similar, but tables in Lua are one-of-a-kind, incredibly powerful tools. You use them to store sets of related data, and since that data is all stored in the same place, it makes it much easier to access and keep everything organized. It's a lot like variables. A variable stores one piece of data, and that's it. Nothing else than that one thing. A table is capable of storing multiple pieces of data in the same variable, except it's a table, not a variable. So let's go through an example from scratch on how to utilize tables. I'm going to start off with our typical message equals 0, and then we're printing message. And after this message variable, let's make a new table. I'll call it test scores. And then when we create a new table, we set it equal to curly braces. In Lua, if you ever see these curly braces, that's how you know that we're working with a table. And since there's nothing between the curly braces, that means it's an empty table. So here we initialize test scores to be an empty table. For this demonstration, we're going to store a bunch of made-up scores in this table. To do this, we're going to assign a score to its own index in the table. Let's go through how to do this. First, we want to write the name of the table, test scores, and then right after, we're going to put square brackets. And then between the square brackets, we're going to put an index. You'll see what this means in just a moment. To start, we'll put in index 1. And I'll set index 1 to 95, for example. And that's it. We assigned our first score to the test scores table at index 1. Now we can move on to the second test score. Let's do test scores and then 2. We'll set this one to 87. For now, we'll put in one more test score. I'll say test scores 3, and I'll set this one to 98. So at this point, we now have a table called test scores, and it contains 3 scores, one at each of these 3 indices. Now, in order to access that data that we just put in, we simply need to write the table name and refer to whichever index we're talking about. So let's say we want to set message equal to test scores index 2. So this is just going to grab whatever value is at index 2, which is 87, and we're printing message here, so we should see 87. Keep in mind that we only assigned values to index 1, index 2, and index 3. What would happen if we tried to access index 4? We didn't put anything in there, so what would happen? If we set message equal to test scores index 4 and try to run this, we actually see nil. So when nothing is assigned to a particular index, it actually contains the value nil. Now, nil is a reserved word in Lua that just represents the meaning of nothing. It just means nothing exists right here in this position. So this method that we're assigning values to the table is okay, but there is a more efficient way to do this exact same thing. I'm going to go ahead and delete these 3 lines, and instead of writing out 3 different lines for those assignments, we can go back up to this original curly brace section and put in those 3 different scores. And that was 95, 87, and 98. So this whole line here accomplishes the same exact thing that we were doing before with the 3 manual inputs for these 3 scores. Or in other words, this value is at index 1, this value is at index 2, and this value is at index 3. And we can test this out. Let's go ahead and set message to index 3 of test scores, and we get 98, which is this value. Although this is the easiest way to put values into a table, there is one other method to doing this that still is important to go through. We're going to redo all of this by simply making test scores start empty, and similar to the way we did it before, we're going to write 3 separate lines, but this time we're going to use this function called table.insert. Same idea from earlier where we wrote our own functions. The Lua programming language comes with a bunch of functions written for us that we can use, and table.insert is one of them. What this function does is simply takes a value and puts it into a table. The function has 2 parameters that we have to pass in before we can use it. The first parameter is the table name, so let's type test scores. That's the name of the table that we want to insert into. And the next parameter is the value that we want to insert. So let's first put in our test score of 95, and we can do the same thing with the other 2 scores and say 87 and 98. Now, the benefit of this table.insert function compared to what we were doing before is that we don't have to specify what index we want these scores to go at. And you'll run into situations where you won't actually know which index you're on. You'll write code that just says, put this value into the table, but you won't know at the time how many items are in the table or if there's any gaps. So this insert function figures all of that out for you. Just a little side note, when assigning values to a table in Lua, it's typical to start at index 1 and then go up from there. It's probably more common for languages to start at index 0, but Lua is one that starts at index 1. But you don't even have to use numbers as an index. You can also use strings. You could say test scores, and then in square brackets, I'll say hello. And then we'll put the value 90 there. Then, similar as before, I can just recall that same data by passing in the appropriate index, and we get 90. But like I said earlier, the one-line approach, if you already know what data is going to be in there, in this case 95, 87, and 98, this is the most compact way to do it. And when you have tables full of data like we do here, it's important to be able to efficiently and easily go through all of that data to either find what you're looking for, do some calculations, or do whatever it is that you need that information for. Luckily for us, Lua gives us a very easy option for iterating through all of the table's entries and examining the data it contains. Remember the for loop from earlier? We can use them in a new way here in order to easily go through the table. And here's how it's done. We can say for, and I'll say I, comma, s in I pairs. and then the table that we want to iterate through is test scores. Do, and then inside the for loop, I'll say message equals message plus s. Now this loop here is going to go through each item in the table, and for each item, it'll perform whatever code is inside of the loop. This I refers to the current index that the loop is on, and this S refers to the value or the data that exists at that index. So in this case, test scores has 3 different scores in it currently. That means that this loop is going to loop 3 different times. The first time, I is going to be 1, and S is going to be the value that's at index 1, or 95. Then at that point, message is going to increase by 95. Then the loop is going to start over again. I is going to be 2 this time. S is going to be 87, or the value at index 2. And once again, message is going to increase. So this loop in general is just going to add up all of the scores together and put it into message. So I'm going to get rid of this line, and we can run and see that the sum is 280. That's what we get if you add 95 plus 87 plus 98. There's one last thing about tables that I'd like to go through. A cool feature about them is that you can add properties to them, which is basically a variable that's tied directly to the table itself. Let's go ahead and add one to this test scores. I'll say test scores.subject equals, and in quotation marks, math. And that's it. We can now get this property by just calling it similar to any other variable, and we should get math. This is a convenient way to clearly mark what each piece of data represents. But really, all that this line is doing is test scores, and then in square brackets, the string subject equals math. These 2 lines accomplish the identical thing. This is just an alternative way of doing this and vice versa. This really demonstrates how flexible tables are, and they let you get really customizable with how your code is organized. Time to talk about the project for this class. I'm going to give you this code here, and I want you to add to it. You can either type all of this code out directly from this video, or you can download a Lua file from the project section of the class, and then copy and paste it all into the same browser from the previous lessons. Here's the problem. I give you this function called sumAllNumbers, but at the moment, it doesn't work properly. This function is supposed to take a number, which we call num, as a parameter, and it needs to add up all of the integers between 1 and num. For example, if we passed in 4, that would mean it would add 1 plus 2 plus 3 plus 4, and the result would be 10. Then it would set that 10 to result and return result. Right now though, when we run, it's always returning 0, no matter what we pass in for this sumAllNumbers function call. What we need to do is fix this so that whatever value we pass in gets utilized within the function and returns an appropriate response. By the way, when we pass in 12 to sumAllNumbers, we should expect the result to be 78. So at first, you should aim for getting at least this number correct here. But of course, in the end, it should be able to accept any number. The total amount of code you have to write should only be about 5 or 6 lines. In order to solve this problem, think back to the previous lessons. One of those topics works particularly well for this problem. When you come up with a solution, be sure to take a screenshot of your code here and post it to the class project page. I'll take a look at it and give you some feedback. If you spend some time thinking about this problem and you can't quite figure it out, be sure to contact me and I'll give some hints. Until then, good luck. After you complete the project, that will conclude this class. Thank you so much for going through this material with me. If you have not already, please leave a review, and if you enjoyed the class, please recommend it. I greatly appreciate the support. Moving forward, I recommend diving deeper into each of the topics discussed in the class. We only scratched the surface of what Lua has to offer. The language has excellent documentation and tutorials on lua.org, so I highly recommend checking out that site. With all that said, I believe that covers everything. Thanks again for taking my class, and I look forward to seeing you in the next one.